Hi everybody. Hey, I wanted to show you a little bit of the design process I'm using to assemble this lower tube assembly that you've been watching me manufacture. So far we've done some cutting and welding and machining to kind of get the parts wrapped up and fit properly. But now what you're seeing here is I'm just making a sketch. Now these are not to scale or anything, these are just a design guide for me to work with. So here I'm showing the inner tube, which was originally a trailer hitch that I got, and I also have a sleeve for that hitch. And right now I'm just kind of superimposing two rectangles with radiuses on the corners, similar to what those look like, to give me you know, a good representation visually of what this looks like. So I have to separate the inner and the outer, so I'm doing that right now, so we can show the relationship between the two parts. So you can see that white line developing there, and I'm going to widen it up just a little bit there. We're going to have to add a little bit more information into this thing. You recall, as we were doing the welding, and you'll see a little bit of that in a few minutes, that I was adding these strips of weld, and I'm inserting them here so you can see what the purpose of those were. I'm going to put one down the center line on each of the four sides, just like I did when I welded it, and this represents those welds after machining. So they were just roughly about 1/4 of an inch wide and roughly 30 thousandths or so thick. So I'll end up with about a 10% clearance. You know, it's not quite a slip fit. I'm calling it a loose slip fit. But here you see a weld up in the upper right-hand corner on the part, and then you see the machining taking down in the lower right-hand corner of the part. And that was the process I used to get all of these, all four sides machined to the proper dimension. Putting one on the top, and then again I'll put one on the bottom, and that will be wrapped up. Okay, now you see the four semi-net surfaces, we'll say, and just putting some notations on here. Now, I'm not using any CAD software for this or anything like that. I'm only using PowerPoint. I just want to show the design intent, so I can have this out there when I'm working on it. Always helps to have a little bit of a visual, you know, like a drawing or something. At least for me, that's how I've always done this kind of thing. And so that's what I'm doing here with the PowerPoint. Okay, now I'm going to make a new sheet to kind of show what the side profile looks like. Here you see that hitch I'm cutting up, and you'll see it over on the bench in a second. There you go, showing the three pieces. So that came off of the hitch. The hitch slides into that receiver, and those two pieces will be making up what we're designing here right now. Again, I'm not going to scale or anything. I'm just trying to show the design intent. So I'm drawing a couple rectangles over, overlaying them, similar to the relationship that you'll see between the tubes, and putting an offset in them like this. So the tube protruding out the top was the hitch, and that will slide up and down inside of that receiver, and we'll be able to guide the lower anvils up and down. Now what I'm doing here is I am putting some, what I'm going to call nut plates. I'm just kind of sketching up what a nut might look like here, and you'll see a nut on 3 nut plates like that. I have all this already, all the material. I just need to put that in. So I'm going to have to do a little bit of a weldment to weld the nut to that plate that's going across there. I'm probably going to use 1/4-inch thick plate, and I'll cut some, I'll say windows, grooves, slots through the side of the outer tube. I'm sorry, on the inner tube, so that I can then weld it from the outside and have it nice and straight and flat. I have to make every effort to make this as accurate as possible, because I'll be having threaded rod going through 3 nut plates, and they have to be in alignment. That's really critical. So I'm going to have to set this up and make it as accurately as I possibly can. I'm just kind of here trying to show a nut, you know, how it will be placed on the plate. There'll be holes obviously drilled. I'll have a clearance hole through each of the plates, and so that there's plenty of clearance. Just want to be able to have a good fit with the nut that you see there. And I will pre-assemble that on the bench so that I know everything is, you know, in line, and then I'll slide it into the assembly and make sure once it's in there I can turn it easily, and then I'll weld the parts in place. I'll figure it out on the bench when I'm going through it. So here I'm just trying to show where the position of each one of these components will be. That thick line you see at the top is a 1/4-inch plate, and I'm going to put a cup there, which is basically I'll cut off a pipe of some kind and weld it to the center of that surface, and the screw will then fit into that cup, and that will keep it centered up there, and that will allow me to raise and lower the slide, the inner slide of the that lower assembly, so I can, you know, increase or decrease pressure on the sheet metal as I'm rolling it in the English wheel. Now here I'm just going to make some notations that describe what we're doing here. I'm trying something new, by the way. The software I use to do my editing now allows me to do screen captures, so I can either capture a picture or a video. And so I did all this real time on my computer, and the whole time I was just letting the software copy it and make this video for me. So I thought that was pretty cool. I might do some more of that type of design work and record it. Always gives me something to refer to, and you might enjoy watching it. I don't know. That's up to you. Shows the thinking process, though, of what I'm doing. So that'll go to the bottom of the inner slide, and then I'm going to make another one that'll be the same, except the right to left dimension will be a little bit wider, and front to back as well, because we're going to be filling the bottom of the outer sleeve, and that will keep the 2 pieces in alignment. Now I'm showing in this view the same thing I showed in the previous view, where those welds are, and I'm showing them. This is more or less a section cut right through the assembly, but there'll be on all 4 sides, you'll have, or I'm putting that yellow strip there, that represents the weld machined down to its proper dimension. Skinny it up a little bit just to show that there's a slight clearance in there. The other thing I'm thinking about doing, and I might add this later because it would be easy to do, I might put a zerk fitting on each side over the top of the weld surface, so I can always, you know, pump a little bit of grease in there to keep it moving easily. I'm thinking about that. Probably do it. Why not? And I'm just kind of filling in the blanks here. Part and nut plate, welded assembly, 2 identical, and then 1 larger on the bottom. Gonna make a copy of that note, come over to the other side here and describe the weld and just a little bit of information about that weld and machine. Calling it a, what did I say there, slip guide surface, and it's not super accurate. It's just something to help keep that thing stable. I don't want the lower anvils on this assembly to be rocking back and forth. I want to try to keep them as stable as possible because it really it really can have an impact on the surface quality of the part that you're forming. Okay, now I'm just going to place that called a cup, basically, that will surround and retain the screw as it pushes up and down. So you see the screw will be fastened solid. I don't want to say solid. I guess what I'm saying is it will be held by the sleeve, and then as it runs through the other 2 nuts, it will allow it to push or retract from the top plate. At least that's the plan. We'll see what happens. Guide cup for the screw. Now we'll insert the screw where that is going to be. And again, you know, this is just a an image or a guideline to get the point across. There's nothing dimensionally accurate about this at all. When I go back out in the shop, I will cut and fit those nut plates, and I will go ahead and weld the nuts on them, cut the slots or the windows in the side of the inner slide, and then insert those assemblies into the slide, the inner slide. And I'll probably put a tack or 2 on them, you know, maybe 1 on each of 2 sides, just to make sure the screw moves freely and easily. And once it does, I will slowly weld those nut plates in place. I really don't want to be fighting that. You know, I think about this, do I just need the top one and the bottom one and not worry about that middle one? But I'm going to try it. And if I don't like it, if it's too much trouble, I can get rid of that nut and just have a clearance hole in that middle plate, but I won't have to have it actually threaded through that surface or that nut. Now I'm going to bring in the ring that will be mounted to the bottom of the screw, and that will give us basically our ability to crank the screw up and down. That's what we're doing here. Like I said, this particular view is more like a section cut through the tube assembly than it is you know, an actual dimensional design. Who needs dimensions? Trying to change the colors up so I can keep the different details easily recognizable. Okay, we're back to the top. You see the weld points, and I need to get that screw assembly and the crank. I'm gonna have to find something for the crank. I don't know. I'll find a metal ring, or actually, I have some tube. I have a tube bender. I've got a steel rod roller. I could probably make something pretty easily. So maybe I'll do that. Just take some 1/4 inch round stock and roll it in my bender. I might have another tool on the way that I might use for that. More to come on that. I'm going to have to, I'll say, clean up that dark blue so I can just have a blue ring around everything. So all I'm doing is making a parallel copy of that circle, and then I'll color it white, and then I'll push that white circle to the back of the design, and it'll give me the appearance of a round wheel that would look something like a steering wheel. There you go. And now the next thing is putting in the spokes of the wheel. I just kind of located them where I want them to be. I didn't do anything fancy like connect them or anything in the middle, but you'll see what I do here just to kind of get the point across. So I went to the first sheet of the design, and I made a copy of that nut plate, and I'm going to place it in here accurately the way it would be when I weld it in place, and where it will live for the rest of its life. So that's what I'm doing here, just kind of fitting it in there to trying to center it up as well as I can too. If you use PowerPoint, you know how you can snap things to a grid, and that's what I'm doing here to try to keep the center line, and that kind of thing. Move that a little bit. That note. And I'm going to put the spokes in now. And I'm going to put them all at 45 degrees to each other. Or to the center lines is probably the best way to say it. I started to just freestyle it and freehand it, but I ended up going back, and you can actually set things at specific angles in here if you want to do that. So I decided to do that. There we go. We go over to the rotate function, and it gives you some options. My guess is a lot of you do use PowerPoint. I use it in my job all the time. I'm with customers. I'm showing them things, you know, presentations and describing designs and concepts and things. And so I'll do a lot of this. I'll make pictures in my CAD software, and then I will just import them in. I don't do video, but I'll just import them into PowerPoint like this, and you know, use that. Now I'll flip this around, mirror it around the vertical axis, and take it over to the other side, and then I'll copy both of them and flip them, mirror image them around the horizontal axis, and put them in position on the top side. Okay. Make a copy, mirror it horizontally. You'll see them flip, and now I can float them into their final position. And you can tell by the sizing here that this is not perfectly on center. I don't care. But if it was in the CAD system, everything would line up, you know, perfectly. So that's what that bottom assembly will look like from the top view, with that wheel being on the bottom. Copy and pasting is quite simple. And if you're a nerd like me, you like to keep your arrows and all that stuff parallel with each other. So I kind of have a problem like that. I have to make things look as neat as I can. Try to make my arrows and lines make up for my welding. Those lines aren't so straight and parallel, but they got the job done. So we'll call that the welded assembly. For the lift ring. Couldn't remember what I called it. You know, I've been trying to learn a lot more about these editing packages and things, and this package I have, I've been using it now for probably a year, maybe a little bit more, and I really like it. And I found something today where, let's say I have a long pause, I can have it automatically eliminate those dead spaces. It recognizes it, and it just really makes it easier and faster for some of the editing. So, okay, so here I'm just going to save this thing and then print out a copy. Got a copy here. And here, I'll take this out in the shop with me when I do the assembly. That's just about it. I hope you guys enjoyed this. Just an easy way to make a simple plan that's easy to save. When I'm done with the pictures, I can throw them in the garbage, and I'll still have the design on my computer if I ever need to refer back to it. So that's about it. Really appreciate you all hanging in there. Next video will be me actually assembling this thing out in the shop. Hope you have a great rest of the evening, and I hope you enjoyed watching this little design process. Take care, everybody.